And moving right along, welcome back everybody, and welcome to session 3, which we've entitled Skills for the Future. Skills, obviously something that has come up a lot in the proceedings yesterday, but also already this morning. Europe's green and digital future will require a wide range of new skills, and we have to see that we have them. Europe EIT manufacturing, of course, is already at it, and we're going to learn now about some of the frontline proposals for reskilling, for upskilling the existing workforce, as well as getting the next generation on board. And it is a pleasure for this to welcome Paola Fantini, who is the director of the education pillar at EIT Manufacturing. She's also vice president of the board of directors at EIT Manufacturing South. And welcome, Paola. I think you're joining us from Milan. Can you hear me?
Yes, I can hear you very well. Can you hear me?
Yes, I can. Very nice to have you with us, Paola.
Okay.
So, Paola, perhaps you can just tell us, before we dive into looking at the projects, how will EIT Manufacturing actually address the necessary skills of the future with its education programs?
Oh, yes. Yes, thank you. Of course, addressing the skills of the future, the relevant skills is vital for us. And therefore, we first of all, we identify the relevant skills emerging from our innovation project and our innovation community, but also liaising with observatories that are in Europe and with our own skill radar. Then we support individuals and companies to be aware of the trends, of their needs and their target, to determine their target. And finally, we develop our education programs and also individually personalize the learning path that include digital, we include virtual reality, hands-on activities, and the collaboration with the industry. So these are the main ways in which we attack this issue and address the skills for the future.
Okay, thanks very much, Paola. I'd like to ask you for this second question. I'd just like you to ask you to keep your microphone really close to your mouth, because we are having a couple of sound issues with understanding you. We're going to see 4 projects now underneath the education pillar, and just let us know why you chose these 4.
Yes, we have, of course, much more projects, and these examples have been chosen because the first one for passion, we wanted to provide through Embryo a very nice example of how you can thrill the pupils and let them play and learn in manufacturing. Mm-hmm. So second one is beyond technical skill, the shaping project will prepare the young generation to cope with a new manufacturing system, with advanced technology, very complex, so that they can develop those skills that are very subtle to address complexity and ambiguity, like critical thinking, teams work, etc. And for the third project, we chose because of human system collaboration. So Mirror Labs provides new ways, new education content on learn how the operator 4.0 can collaborate in a transparent way with the robots and artificial intelligence, equipped and supported by augmented reality. Last but not least, wider collaboration, TF NoNet project shows how industry and academia can collaborate and learn from each other and co-create in order to address problems and challenges of the shop floor. So this is the criteria that we have used to choose this project to provide you with the
thank you very much, Paola. Let's
you.
Dive right into the first of the education projects, and we're going to take a look right now at Mirror Labs, which is presented by Doris Aschenbrenner.
Welcome to our EIT Manufacturing presentation on the project Mirror Labs. Mirror Labs is enabling communication between users and robots. In order to tell you more about this, I'm going to show you a small video. The development of human industry can be divided in 4 different revolutions. First, mechanical revolution, then electrical power was introduced, then computer and automation were thrown into the mix. And now we are on the brink of a 4th industrial revolution where more complex systems, artificial intelligence and cyber-physical systems are introduced. With all of these extra ingredients, our machines get much more complex and less transparent in phases of high demand for safety and efficiency. Humans and their robotic colleagues need better ways to communicate. In other words, apart from the Factory 4.0, we also need the Operator 4.0. This can be realized with augmented and virtual reality when we develop an augmentation layer that helps the worker to understand his environment. And this is our mission, what we aim for in the project Mirror Labs. We are partners from all over Europe and we have similar hardware with respect to robots and augmented and virtual reality. We work together to build mirrored labs and a joint infrastructure which connects robots and augmented and virtual reality so that humans and robots can work together in a better way. Here is how this framework looks like. The user wears a Microsoft HoloLens and you can see his perspective on the left. And the other user is controlling the robot and you can see that the digital twin seen by the HoloLens is moving in the same speed. This can be used for displaying additional information or even the future. So what will the robot do next? This would be very helpful for the worker, don't you think? This is our mission, and what we achieved so far is we have established 7 mirror labs. We have developed 18 nuggets that can tell you much more about how humans can work together with robots and how this infrastructure works, and of course our ICT framework. If you want to know more, visit our webpage at mirrorlabs.eu or our booth. I look forward to see you there.
And thanks very much to Doris Aschenbrenner, and we will speak to her in just a moment. But we've got 3 other projects to have a look at, and next up is the Embryo project presented by Lander Galdos.
Good morning. My name is Lander Galdos. I'm the coordinator of Embryo project together with Arduino and TU Darmstadt. And the topic I will address today is the engaging pupils into manufacturing. I would like to thank EIT Manufacturing for selecting us to be in this main stage. It's a great honor. What was the motivation? You know that the image that pupils, young students, and society in general has about manufacturing is that it's a dirty job, boring, work for men, tedious, updated, poorly paid. But isn't this an old image, an old picture? I can assure it is. The companies that we have nowadays in Europe, they are high-tech and they are producing high-tech products, okay? And we need to maintain this because manufacturing is really an important sector for Europe. So Europe urgently needs new skilled people for advanced manufacturing. And this was the motivation of Embryo. To be honest, Embryo started like 5 years ago when one nephew told me, Uncle, can you teach us about manufacturing? There was the option to go there to teach them in 2 hours. And I do a practicum, a very simple one, where we cast their school logo using a low temperature melted alloy. They were doing their own molds by hand using sand, and we were casting the logo. And as time was passing, I observed that they were having a nice time and they were enjoying that. With this philosophy, we have then launched Embryo, and we have created new lectures, new lecturing methodologies using the learning by doing method, and we have created a new tabletop press so that students can do hands-on activities. So first, the students learn about Arduino, sensors, and digitalization. Secondly, we teach them about manufacturing processes, about metal bending, about sustainability. And finally, they mount the press you see in point 3 and the control board. They do the programming, the setup, and we ask them to design a product and to manufacture the product using a soft aluminum alloy using the press. We have applied this in 13 secondary school classrooms in Spain and Germany. We have taught 270 pupils that are 14 years old, and the results are very good. The schools are very happy, and they tell us that they are having a fun time. Embryo will continue in 2021, and we want to do another educational product that will be to manufacture our own machines. We think it's more flexible to involve the creativity, and this all will be available for you. So if you are interested, join us. You can contact us in our website, or you can visit the virtual booth we have in this summit. Okay. Thank you very much, and see you next time.
Thanks very much to Lander Galdos with the Embryo project there. And our next project coming up is TF-NoNet, presented by Harry Bikas.
Good morning, everybody. My name is Harry Bikas. I'm a research engineer at the Laboratory for Manufacturing Systems and Automation, and I'm going to present our activity, TF-NoNet. When one looks at knowledge, skills and competencies come up as the main building blocks. However, the skills and competencies required by the labor market evolve at a high rate. According to the ManuFuture Vision 2030, 35% of the core engineering skills needed have changed between 2015 and 2020, leaning towards multidisciplinarity, creativity, and so-called soft skills that cannot be effectively taught in a typical classroom. In addition, due to the rapid evolvement of skills required, academia needs to be able to follow industrial needs to generate the right kind of professionals. Most European countries have a well-developed educational system on every level. This is accompanied by owning a lot of high-value industrial equipment, particularly in the most industrialized countries, which is unfortunately quite often underutilized. Meanwhile, manufacturing is one of the main economic and societal pillars of Europe since the mid-1700s. Europe is home to some 2 million manufacturing SMEs, but also to some of the most renowned large enterprises worldwide. The competitive advantage of European manufacturing enterprises is their know-how. Nevertheless, they still face a number of technical and non-technical challenges in their daily business. In addition, most of them are relatively slow as it regards innovation adoption. On top of this, there has been a huge unexpected disruption in the form of COVID-19, with a significant impact on the educational institute's operation. All aforementioned facts point to one specific need: an effective remote collaboration paradigm aiming at knowledge exchange. TF-NoNet proposes to take advantage of the unique characteristics of all aforementioned actors and connect them together to the ecosystem benefit, forming a knowledge exchange network. As such, TF-NoNet aims to deliver a program where students, researchers, and companies work together to mutually develop skills, promote and share expert knowledge through co-creating solutions to industrial manufacturing challenges. The approach is based on extending the established teaching factory paradigm on a network level, combining it with open innovation practices. The TF-NoNet Knowledge Exchange Network comprises both leading industrial partners as well as renowned universities, mutually benefiting from the approach. Benefits arising from such a synergistic approach include effective exploitation of the expertise of individual partners, sharing of high-value infrastructure through virtually interconnected labs, transitioning to a teaching and education scheme more suitable in the post-COVID world, closer matching skills and gain attractiveness, as well as promotion of multi-nation and multicultural communication. To prove the value of the concept, 3 pilot activities are currently running, involving 7 organizations and more than 80 trainees across 6 European countries. Looking forward in 2021, the consortium partners aim to expand the scope of the network to include additional modalities such as professional training and implement at least 8 pilot activities, simultaneously tripling the number of participants that benefit from the approach. Thank you very much for your attention. For more information, please visit our virtual booth at the summit, our website, and follow us on the social networks.
And thanks very much to Harry from TF NoNet. And finally, last but not least, shaping the next generation of manufacturing professionals is the project that will be presented by Gil Gonçalves.
Hello, good morning. Thank you for coming. I'm going to present you the project Shaping the next generation of manufacturing professionals. Today, industry stands on the brink of a digital transformation. The transition to a new paradigm towards smart manufacturing is taking place, leading to the fourth industrial revolution. With this revolution comes a new mindset. And with a new mindset comes the need to educate young students to become the manufacturing engineers of the future, aware of the main transformations, processes, and concepts surrounding the smart manufacturing paradigm. With the exponential growth of digital technologies, such as artificial intelligence, Internet of Things, sensors, 3D printing, robotics, and cloud computing, the industrial sector is looking for people that are able to solve ambiguous, open-ended, and ill-structured problems. And here is where the project Shaping and its mission comes in. Shaping is all about raising, in an inclusive way, the interest of young students for activities in the field of manufacturing, especially within the scope of the EIT. We want students to interact and critically engage with challenges related to smart manufacturing from an early age. We want to motivate them to consider a possible career in manufacturing. A series of activities such as open days, seminars, digital escape rooms, workshops, and teaching factories for kids will help and assist universities, research and technology organizations, namely FEUP, INEGI, Tecnalia, LMS, and STUBA, in attracting and engaging these young students. We are now targeting at least 10 schools and near 800 students between ages of 15 and 18 from Portugal, Spain, Greece, and Slovakia. In its turn, for 2021, we are targeting 2,500 students from 5 countries between ages of 12 and 14, and we'll also start by involving 40 teachers. In order to do this, new activities will be outlined and other outputs will be introduced, such as a public repository, a set of demonstrators, new seminars, videos, and training for teachers. Within these activities, we will be addressing topics like additive manufacturing, augmented reality, digitization, robotics, Internet of Things, and other related subjects. Long story short, Shaping is purely about impacting young people and making them the next generation of manufacturing engineers. And you know what? Even if only a few chose this path, or even if we only generate interest in this area, our mission is already accomplished. It's all about creating awareness. I invite you to find out more at shaping4youth.eu and also to follow us on LinkedIn, Facebook, and Instagram. You can also visit our summit booth. Stay tuned, stay safe, and get ready for the future. It's going to be quite a ride. Thank you very much.
Gil Gonçalves there bringing us the Shaping project, and I'd like to get Gil onto the screen along with all of the cohorts of this education pillar group. Very diverse group of projects that we have there, so we need to get Doris and Lander and Harry and Gilles and of course Paola Fantini, who is director of the education pillar. Obviously you must be impressed with what we've just seen, and I've got a question. I'll start off I think with Doris from Mirror Labs. Welcome to all of you. Enabling communication between users and robots. Can you just tell me quickly, are you seeing an increased uptake in collaborative systems with the way things are going in manufacturing now?
Yeah, so the development of these collaborative robots has increased, the market has increased immensely, and there are a lot of applications that are now possible as you have the possibility to work within close proximity to the robot. So the robots are not caged anymore as the typical industrial robots would. The collaborative robots can be operated next to a human, and that also kind of opens up the possibility to collaborate directly with humans, and that's very exciting in my point of view.
Absolutely, very exciting stuff, and I'm sure we will be hearing more from you in the months and years to come. Over to Lander now with the Embryo project, which was changing perceptions of manufacturing by boosting creation for kids in schools. And I'm just wondering, Lander, you did the pilot in Germany and Spain, as you said. Are there any hopes to scale up this project in other European countries? We've got a bit of a sound problem there with Lander. Lander, we can't hear you. Can you double check that your microphone is unmuted?
Sorry.
There we go. There we've got you.
So yeah, there is a idea to upscale this in an Embryo 2. We will add also companies from other countries, and also our main industrial group, which is Mondragon Group, and this will be helping us to attract industry, and that this industry helps us to find schools nearby. Okay, and yes, the idea is to stay growing, definitely.
Looked like an absolutely fantastic project, and thank you for bringing that and sharing that here with us at the EIT Manufacturing Summit. So over to Harry now from TFNonet. And I'm just wondering, this is a knowledge exchange program, and I'm just wondering, because you mentioned the COVID crisis, how can SMEs gain an advantage from the teaching factories, especially in the wake of COVID?
Thank you for the question. We think that SMEs are the ones who can benefit more from such knowledge exchange schemes, because essentially large companies often have the capabilities internally to develop such skills and to train people and to gain new knowledge by internal R&D, while SMEs normally lack this kind of luxury, let's say. So what we want to provide to them is a way to innovate, a way to gain access to new knowledge by engaging with academia. And in the wake of COVID, we try to do that through a virtual cooperation scheme, through the web, through a remote collaboration that is the core of TFNonet, so that we lift geographical limitations, we lift travel limitations, and essentially we lift the barriers that are imposed by COVID.
Thank you very much, Harry, and good luck with scaling that up as well. Now over to Jill, because you are shaping also the next generation of manufacturing engineers. I found that very interesting, and the question I have to you is just how did the kids react to the smart manufacturing demonstrators, and how can these be used in the years ahead?
Well, the reactions were really quite enthusiastic. They loved the concepts that were presented. They loved to play with it, and it's really interesting. So we were targeting kids which are already approaching that time when they have to decide what their future career will be. And I think that the impact was quite positive. So they found this technology is quite interesting. The way that we presented this to them by involving them in games, in experiments, being able to touch and to experience how things are done, I think it's quite motivating for them. And now the next steps will be to start involving kids at younger ages. So next year we will start to addressing younger kids, starting at 12 and until 14, and this will definitely also make the difference, because it will open up new possibilities to experiment different things, to start introducing also different things. For example, programming will be involved as well at younger ages, which means that we can introduce them also to new ways of thinking and new ways to rationalize about problems. Definitely, this will make a difference in the way that they see their possible future career, and hopefully we will have them as students at the university, and then they will be the next manufacturing engineers.
The next generation, and I can only wish you all the best with that. I have a 12-year-old daughter myself, and I think that it's absolutely the right direction to be going even younger, get them young, and getting people interested in manufacturing and obviously in the scientific disciplines. So a terrific bunch of projects. Paola Fantini, just to come to you on the end of this session, how encouraging are the results of this first year of EIT manufacturing for you?
Really encouraging. We are proud, I would say, and excited about the results that we have been built. And yes, we are aiming in 2021 to, of course, leverage on this project, scale up them, extend the outreach. To cross-contaminate, because we have a lot of very nice ingredients here that we want also to bring to our academic master and PhD programs, for example, and also contamination among the areas that we have, or the project that we have now in our portfolio. And of course, we will have something new coming in 2021. We have also new partners bringing in new ideas and new challenges. So this is our plan for 2021, for sure. Very
thank you so much
by this experience.
Thank you so much, Paola Fantini. We are having a couple of a bit of an issue there with the sound from Paola. Obviously, she's talking about cross-pollination, and I think the cross-pollination that we can see, the potential that we can see with these 4 projects that we've been introduced to today. Obviously, a lot of momentum to work with there going into 2021. I'd like to thank all of you, Doris, Landa, Harry, and Gilles Gonçalves, and Paola Fantini for joining us for this session 3. Thanks so much for being here and for giving your insights and knowledge to the EIT Manufacturing Summit 2020. And my dear participants, it is time for a short break before we continue with our session 4. So go have a stretch, have a cup of tea. I think you've got just a couple of minutes, and we want to keep our senses sharp because there's a lot more coming at us. So see you in a few minutes. Thanks very much.
I would rather twist that around to a metaphor. We have for a long time said that nothing will be manufactured that is not completely described in a digital world. And what we will see in the future is that nothing is manufactured that is not completely both in the manufacturing world and the product world.
Digital value-added networks are established. Manufacturing data have a measurable value and are traded on the market.
Cognitive computing and analytic techniques will enable production environments to self-configure, self-adjust, self-optimize.
We are now living the 4th industrial revolution, and we are heading towards the 5th one, characterized by a confluence between machines and humans.
Manufacturing sites will become so flexible and interconnected that we will be able to empower end users to customize its preferable choice.
Earlier, when you should manage work, you separated the brain and the hands from some people. So some people did the work and some other people use the brain and find out what they should do. We cannot separate these two. All people's brains needs to be used, and all the hands in a company needs to be used in an integrated manner. That is how we succeed in the future.